Enzyme immobilization.
Enzyme immobilization can be defined as confining the enzyme molecules to a distinct phase from the one wherein the substrates and the products are present.
Advantages of immobilized enzymes.
1. Increase in stability and functional efficiency of the enzyme. 2. Reuse of the enzyme is possible without compromising the quality. 3. Products can be obtained without contamination with enzyme. 4. Control of enzyme function is easy. 5. Suitable for industrial and medical use. 6. Compatibility with multi-enzyme procedures. 7. Continuous process can be set easily.
Disadvantages of immobilization. 1. Biological activity of enzyme might get lost during immobilization. 2. Immobilization is an expensive affair requiring sophisticated equipment and skillful persons. Methods of immobilization.
1. Adsorption immobilization.
2. Entrapment immobilization. 3. Microencapsulation. 4. Covalent binding.
5. Cross-linking.
Adsorption immobilization. Adsorption involves the physical binding of enzymes, or cells, on the surface of an inert support.
Support materials comprises 1. Inorganic, alumina, silica gel, calcium phosphate gel etc. 2. Organic, starch, sephadex, SMC, decellulose, sephadex, etc.
Adsorption of enzyme molecules on the inert support involves weak forces such as van der Waals forces shown here in diagram A and hydrogen bonds as shown in the diagram B. Adsorption of enzyme molecules on the inert support involves weak forces such as van der Waals forces and hydrogen bonds. Advantages. One of the easiest methods of immobilization. Low-cost operation. No skill is involved. Disadvantages. The adsorbed enzymes can be easily removed by minor changes in pH, ionic strength or temperature. Not much applicable to commercial processes. Enzymes can be immobilized by physical entrapment inside a polymer or gel matrix. The size of the matrix pores is such that enzyme is retained while the substrate and the product molecules pass through. Technique is commonly known as lattice entrapment. In the entrapment, cells or enzyme molecules are not strongly bound to polymeric support, rather they are physically trapped in a non-reactive polymer matrix.
Methods of entrapment. Enzyme inclusion in gels. This is an entrapment of enzyme inside the gels, as shown in figure A.
Enzyme inclusion in microcapsules. In this method, enzymes are trapped inside a microcapsule matrix. The hydrophilic and hydrophobic forms of the matrix polymerize to form a microcapsule containing the enzyme, as shown in the figure C. Enzyme inclusion in fibers. The enzyme is trapped in fiber format of the matrix, as shown in figure B. Advantages. Useful for immobilization of enzymes as well as cells. One of main methods used in industry. Disadvantages. Leakage of the enzyme from matrix. Applications. Entrapment of cells is useful for industrial production of amino acids, L-isoleucine, L-aspartic acid, L-malic acid and hydroquinone. Microencapsulation. Microencapsulation is a process of entrapment where microcapsules of semipermeable membrane containing active enzyme molecules are formed. It is a type of entrapment or a process of spherical particle formation wherein liquid or suspension is enclosed in a semipermeable membrane. Membrane may be polymeric, lipoidal, lipoprotein-based or non-ionic in nature. There are three distinct ways of microencapsulation. 1. Building of special membrane reactors. 2. Formation of emulsions. 3. Stabilization of emulsions to form microcapsules. Applications. Microencapsulation is useful for immobilization of enzymes and mammalian cells. For example, pancreatic cells grown in culture can be immobilized by microencapsulation. Hybridoma cells can also be microencapsulated. Demerits. It is relatively complex operation to perform. Activity of enzyme might be lost during process. Covalent binding. One of the widely used methods of immobilization. Immobilization of enzyme can be achieved by creation of covalent bonds between chemical groups of enzyme and chemical groups of the support. Covalent bonding sometimes lead to some loss of activity of an enzyme activity. Inert support usually requires pretreatment before it binds to enzyme. Approaches of covalent binding.
Cyanogen bromide activation. Inert support materials such as cellulose, sepharose, sephadex containing glycol groups are activated by cyanogen bromide CNBr, which then binds to enzymes and immobilize them.
Diazotation. Some of the support materials such as amino derivatives of polystyrene, aminobenzyl cellulose are subjected to diazotation on treatment with sodium nitrite and HCl. They in turn bind covalently to tyrosyl or histidyl groups of an enzyme. Peptide bond formation. Enzyme immobilization can also be achieved by the formation of peptide bonds between amino or carboxylic groups of support and carboxylic or amino groups of the enzyme. Activation by bi- or polyfunctional reagents. Some of the reagents such as glutaraldehyde can be used to create bonds between amino groups of enzymes and amino groups of support, for example amino-ethyl cellulose, albumin, amino-alkylated porous glass. Cross-linking. Immobilization does not require solid support for immobilization. Enzyme molecules are immobilized by creating cross-links between them through the involvement of polyfunctional reagents. These reagents in fact react with the enzyme molecules and create bridges which form the backbone to hold the enzyme molecules. Several reagents can be used for cross-linking. Some of them are glutaraldehyde, diazobenzidine, hexamethylene diisocyanate and tornadiisocyanate. Glutaraldehyde is most extensively used. It reacts with lysyl residues of the enzyme and forms Schiff space. Cross-links formed between enzyme and glutaraldehyde are irreversible and can withstand extreme of pH and temperature. Advantages. Quite simple and cost-effective method. Most reliable method as far as commercial applications are concerned. Immobilization of enzyme is irreversible and can withstand extreme of pH and temperature. Applicable for several industrial enzymes, for example glucose isomerase, penicillin amidase, etc. Disadvantages. Risk of denaturation of enzyme is great due to treatment with polyfunctional reagents.